Hello?
Yeah, hi Lucas.
Hi.
So rebooting did the trick?
Yeah.
It's,
I don't know why my computer did that.
I know, I have to reboot all the time. I probably have to reboot about once a day. Every now and then my mouse just starts going crazy when I'm in an online session. And the only fix is to reboot my computer.
Huh.
So, did you have a good Thanksgiving?
Yeah, did you?
Yeah, I did. It's nice to have a little break. So let's see.
Yeah.
You probably got a final coming up in a couple of weeks?
Yep, but we're not reviewing for that yet.
Okay.
I have it the week of the 14th, I believe.
Okay.
The 15th and 16th.
Okay. So what are we going to do today?
Sine, cosine, like graphing.
Okay.
And stuff like that. And I have some problems for...
Okay, before you give me those problems, let's make sure you get these both memorized. What's this the curve of?
Sine.
And what are my 5 important points on the x-axis?
0, 90, 180, 270, 360.
Very good. And what's that point? What's that point?
-1 and 1.
And the only difference in the cosine curve is it starts at 1, goes down through the x-axis at that quarter point, hits its minimum at that quarter point, comes back through the x-axis at that quarter point, and finishes where it started there.
Yeah.
So there's your sine and cosine. If you've got everything memorized there, you'll be able to answer most questions. Okay, so what are your problems?
First question is select the functions that have identical graphs, and the functions are y equals sine quantity, 3x plus pi over 6. And then the next one is y equals cosine quantity 3x minus pi over 6. And then the last one is y equals cosine 3x minus pi over 3.
Okay. If we go back and look at our sine and our cosine curves, the sine curve, or you could say the cosine curve, is merely a phase shift away from the sine curve, right?
Mm-hmm.
In other words, if that's the sine curve, and this is the cosine curve, a phase shift moves everything laterally. So if I were to move the cosine curve to the right by pi over 2, it would look like this. Notice that that's the sine curve.
Yeah.
So I can say that the sine of x is equal to the cosine of x minus pi over 2. Always.
Yeah.
Hold on a moment. Did I do that right? Yeah, it looks like I did. Okay. So which one of those functions is phase shifted by pi over 2? Okay, hold on a moment.
I think it's going to be the third and the first.
Well, first of all, let's talk about phase shift. If I want the phase shift of this function I have to factor out a 3. So I could write it as the 3 in front. What's left over is this, right?
Yeah.
Okay, and now if I do the same thing to everything, you're saying that one of these two is identical to the first?
No, it says select the functions that have identical graphs. So any of the three, or like in the three, there's going to be one that have identical graphs.
I got it now. I got it. So it might be the two cosine curves.
No, but because they have... Oh, yeah, it could.
But probably not, because this has a phase shift of pi over 18. This has a phase shift of pi over 9. That's not going to result in the same curve.
Mm-hmm. So...
I'm thinking for a moment here. Notice that if I'm looking for this pi over 2 differential, the difference between plus pi over 6 and minus pi over 3 is 3 pi over 6. That's pi over 2. So this curve right there should be the same as that curve. Let me graph them on Wolfram alpha, and we'll verify that that's true. Okay, there's that curve. And now let me put the same curve, cosine of 3x minus pi divided by 3. Put both of them on there at the same time and see if they overlap. They do. The sine and the cosine on the same curve, and both lines you only see one line, so they do overlap. Okay, so what that tells us is that we don't want to factor out that 3. Because all we want to do is find out which one of these things differ by pi over 2.
Yeah.
If I'm on a number line and I'm going from plus pi over 6, in other words, here's my coordinate system, here's plus pi over 6, here's minus pi over 3, if those are separated by pi over 2, then we have our answer. Well, if I take pi over 6 and I subtract a negative pi over 3, I get 3 pi over 6 or pi over 2. So they are pi over 2 apart.
Yeah.
And that's why they have the same graph.
Yes.
Okay, what else?
This one is graph the equation, and the equation is y equals cosine 1/2 quantity x plus 100.
Do you have a standard that your school uses? Is this the standard?
I don't think so.
Is this the standard? There are 3 different standards.
I don't recognize either of
The
those.
third possibility
I think it's the third one.
Okay. It matters because the best one really is the first one. The reason is, from the first one, you can figure out the period based on B, and you can figure out the phase shift, which is C. And the vertical shift is D. If number 2 is my standard, then I have to factor out the B before I know what the phase shift is. In other words, the phase shift is C divided by B. And if it's the third one, then the phase shift is negative C divided by B. So depending on which one you use as your standard, or which one is the equation in the form of, then that's going to tell me my phase shift. Now notice that this one is actually in type 1. So what would the phase shift be?
The phase shift would be right 100?
It's negative 100, which means left.
Yeah.
In other words, a
left.
positive C means to the right, a negative C means to the left.
Yeah.
Okay. What is the period? First of all, B is 1/2, which makes the period what?
2? No. 180?
First of all, the period is 2 pi divided by B. So this period would be 4 pi.
Oh.
In other words, when you multiply by a B that is less than 1, you are horizontally stretching the function.
Yeah.
In other words, if I wanted to plot cosine of 1/2 x, it would go out to 4 pi. In other words, I would have to stretch it horizontally because I am multiplying by a number less than 1.
Yeah.
And that's the period, is 4 pi, the place to where this function starts and where it starts to repeat. So this would be cosine of 1/2 x. Well, if I take this function and horizontally shift it to the left by 100, then I will have this. So that's all I do, is I go to minus 100 on the horizontal axis, and I start my curve here instead of at the origin. And I'm going to go out 4 pi. Now this is a bit of a strange problem because they made the phase shift a number instead of some number in terms of pi, which you would expect it to be. But that's okay. 4 pi is 4 times 3.14.
We've been working primarily in
Radian?
Degrees.
Oh, in degrees?
Degrees.
Well, this is never in degrees, the phase shift. I guess it could be, but I've never seen it in degrees. Every sinusoid function I have ever seen, this number is in radians.
Yeah.
So I'm presuming it's in radians here, but I don't know for sure. I suppose it could be degrees, but it doesn't really matter. If it's degrees, then this would be 720 here. That's what 4 pi would be. It would be 720 degrees. So then I would just move everything over by 100, and I would go from minus 100 to 620.
Yeah.
And I suppose that if you think it's in degrees, then that's what I would do, is I would start here, I would end at 620, I would quarter that up,
Yeah.
and then I would start my cosine curve there, I would come back down through there, I would come back up through there, and I would go to there.
Yeah.
Okay. Have you had all 4 of these letters? I mean, have you dealt with A, B, C, and D?
I think we just yeah, we have.
Okay. Every one of them does something different to the graph. In other words,
Yeah.
A vertically stretches it. B, some B other than 1, either horizontally stretches or horizontally shrinks it.
Yeah.
D is just like a polynomial. It's a horizontal shift. It's either left or right. In other words, that's the same as x minus h if you're dealing with a polynomial function. And
Yeah.
D is a vertical shift. In other words, C and D do not change the shape of the graph. They only move it up or down or left or right. Whereas A and B do change the shape of the graph. They can narrow it or flatten it. And the basic method you use to graph any of these is to look at your function, figure out what A is, what B is, what the period is based on B, what C is, what the phase shift based on C is, and what the vertical shift is. And you apply each one kind of independently. And whatever you end up with is what you end up with.
Yeah.
Okay? Got another one of those?
Next one is find the exact values of the indicated trigonometric functions, right fractions in lowest terms.
Okay.
And it's a right triangle with sides 33, 55, and 44.
You said a right triangle?
Yeah.
The side lengths are what? I'm sorry, 33?
33, 55 is the hypotenuse. And 44 is the other side.
Notice that that is a multiple of a 3, 4, 5 triangle. It's a 3, 4, 5 triangle times 11.
Yeah.
Okay. So what do they want? The trig functions? Which one?
Indicated, which are so the angle they want is adjacent to the 33 side.
This one up here?
Yeah. And it's sine theta, cosine theta, and the angle measure of theta.
What's sine theta?
44 over 55 or 4 over 5.
Cosine theta?
3 over 5.
And theta?
I haven't got it. It's gonna be
the inverse sine of 4 over 5, or
yeah,
the
inverse cosine
of 3 over 5. In other words, this is kind of by definition. If the sine of theta is equal to 4 over 5, then by definition theta is equal to the inverse sine of 4 over 5.
Yeah.
These are kind of like if and only if. If this is true, then this is true. And if this is true, this is true. And another way of thinking about it is, well, I could take the inverse sine of both sides. So if I took the inverse sine of the left side and the inverse sine of the right side, well, the left side produces just theta. So theta is equal to the inverse sine of 4 over 5. Do you have your calculator?
Yeah, I just did it. It's 53.1 degrees.
Yeah, most people are quite familiar with the 3, 4, 5 triangle, but if you ask somebody what these angles are, they wouldn't mostly be able to tell you.
Yeah.
They're odd. 53 and 37 are those two angles.
Yeah.
And they always are that on a 3, 4, 5 triangle, but oddly enough, it's rare that you need to know those angles. The only thing you really need to recognize are 3, 4, 5 triangles most of the time.
Yeah.
Okay?
All right, the next one is convert the radian measures to degree measures. Use the value of pi found on a calculator to round the answers to the nearest decimal places.
Okay. So the nearest how many decimal places? Nearest decimal place?
Two.
Two decimal places. Okay.
Yeah, nearest 2 decimal places.
Okay.
The first one is negative pi over 5.
Okay, what is the conversion factor?
It's pi over 180.
Or is it 180 over pi?
This time it's 180 over pi.
Right. In other words, it's one or the other, depending on whether you're going from radians to degrees or from degrees to radians. The way to tell is this is radians, and I want to lose the radians. So if I want to end up with degrees, I need the radians to be in the denominator, because they will cancel and I'll end up with degrees. 180 over 5 is 36 degrees. Negative 36 degrees.
Yeah.
Okay?
The next one is convert degrees to radians.
Okay.
And then it's 570 degrees.
So this time we're going to multiply, since we want to lose the degrees goes with the 180. We'll multiply by pi over 180. And
So
that goes in there. Do you have a calculator? What is that number? What's 570 divided by, what's 57 divided by 18? That must be
3.16.
Let's leave it as a fraction as opposed to a decimal.
3
It's like,
and
let's see.
3 and 1/6. So
19/6
yeah.
pi. Now, when you get an angle that's outside of the unit circle, does your teacher want you to convert that to inside the unit circle?
No, I don't think
This
so.
is the answer. Okay. It's worth knowing that every angle that is either plus or minus 2 pi from this is the same angle on the unit circle. In other words, if I look at 30 degrees, well, that's the same as 390 degrees, which is the same as 750 degrees. Now, when I say the same as, I'm not sure that that's technically correct. It has all of the same trig functions. In other words, the trig functions, all 6 of them, of 30, are the same as the trig functions of 390 and 750. In other words, all coterminal angles have the same trig functions. So I can leave this as 19 pi over 6, but if I wanted to know what the equivalent was, I would subtract 2 pi from that, and I would get 7 pi over 6, and that is 210 degrees, which would also, I would get by subtracting 360 from 570.
Yeah.
But on a test, I would guess this is the right answer. 19 pi over 6.
Yeah.
What else?
The next one is convert the angle to decimal degrees and round to the nearest hundredth of a degree. And the angle is 238 degrees, 54 minutes, and 38 seconds.
Let's first of all convert this to a decimal degree angle.
Yeah.
How many seconds to a minute?
60.
How many minutes to a degree?
60.
So it's really since there are 3,600 seconds in a degree.
Yeah. So it would be...
So 238 plus point what plus point what? What's 54 divided by 60?
0.9.
0?
Shouldn't I...
Oh,
No, it's just... I shouldn't have used a calculator for that.
oh,
And then,
yeah, it's 0.9, you're right. And then what's 38 divided by 3,600?
Oh, no. Okay, 3,600. My calculator is dying.
Okay, I can do it on mine.
It's dead. Oh.
38. Whoops. I hate my calculator on my phone. Let me use my other calculator. 38 divided by 3,600 equals 0.010555. So now if I add all 3 of those together, I get 238.910555. Round that off to the nearest hundredth.
Yeah. So 238.911.
No, just 91. In other words, oh, no, well, no, if we're going to the nearest hundredth, this is the nearest hundredth.
Yeah.
Now, do they want you to convert this to radians also, or they just want it to convert it to a decimal degree?
Just to a decimal degree and then round it to the nearest hundredth.
Okay, so if I'm rounding this to the nearest hundredth, it's 238.91. In other words, this rounds down. Gets dropped. The 0.55.
Yeah.
So there's your answer. Now, there's multiple ways to do these kind of problems. I don't know. This seems like as good a way as any to do it. Okay?
Okay, the next question is From a boat on a lake, the angle of elevation to the top of a cliff is 39 degrees 39 minutes. The base of the cliff is 770 feet up from the boat. How high is the cliff to the nearest foot?
700 and what?
70 feet.
We want to know why, right?
Yeah.
Okay. What trig function will allow me to get y?
Tangent.
Equals what?
Y over 770.
Which means y is equal to 770 times the tangent of that. How do you get this number?
Divide 39 by 60? No.
No, that's right. We want to convert it to a decimal. I'm not sure your calculator will do. In other words, this is equal to 700 times the tangent of 39.65 degrees.
Yeah.
I'm not sure your calculator will take degrees and minutes. It might. It probably does have a setting where you could set it on degrees and minutes. But it's probably just as easy to convert it to a decimal and then put the decimal value in. So you'd want to take the tangent of 39.65 as long as your calculator is in degrees. You always want to be aware of whether your calculator is in degrees or radians, because if you think it's in one and it's actually in the other, it'll mess you up. Sometimes you won't be able to tell. Sometimes you'll be able to tell because it'll be obvious that you're not in the right thing. In other words, if you type in what's the sine of 90 and you don't get 1, you know you're not in degrees.
Yeah.
Or if you type the sine of 30, you should always get 1/2. Okay. Do you need an answer for this? Do you need me to do it on my calculator?
I got it. It's 580 feet.
Okay. There's actually a very clever way to determine the height of that cliff, even if you do not know how far away from it you are. Let's make it simple. We're in a wagon train coming west, and we see Pikes Peak. And we know we're a long ways away from Pikes Peak, and we want to know how high it is. Well, I can take a reading from, I don't know how far away I am. In other words, this is an unknown distance.
Yeah.
However, if I take a 30-degree reading to the top of the mountain, and then I move some distance forward, say 1,000 feet, and I take another reading to the top of the mountain, now that's 40 degrees. That's going to allow me to calculate not only how high the mountain is, but how far away from it that I am.
Yeah.
It's really kind of cool that Trig can do that. In other words, actually, the Western pioneers that settled the country, they could have done this exact thing. And you can see Pikes Peak from about 100 miles from Denver. In fact, if you're driving to Denver on I-70 sometime, the very first thing you see is Pikes Peak, which is interesting because it's down close to Colorado Springs. It's not even close to Denver. But that's the first peak you see. And it's about 100 miles. But is all these pioneers had to do was to take an angle reading, move in 1,000 feet, take another angle reading, and you can figure out not only that X is about 100 miles, but that Pikes Peak is like 14,000 feet high, which is pretty cool when you think about it, that no matter how far you are away from the mountain, you can figure out how high it is.
That is from see if you could see it from sea level, though.
Well, this does presume that it's flat as opposed to the Earth is curved. So you're right. When you take into account the fact that the Earth is curved, it does change the trig a little bit. But
well, not even that, because it's like 14,000 feet from sea level if you went straight down, but you're up higher, so it'd be
yeah. So all that's gonna so all this is gonna tell you is why. And if the base of the mountain is already at 5,280, then you're right. This won't be 14,000 feet. It'll be like 9,000.
Yeah.
But even still, it'll tell you the height of that mountain above the ground level.
Yeah.
That's pretty valuable. Imagine you're in that wagon train and you're still 100 miles from that mountain and you're trying to figure out, well, am I going to be able to cross that mountain or not? And the key thing that would determine that is how high is it? So knowing that you're looking at a mountain that's 9,000 feet above the ground would be significant. Considering you might only move 20 miles a day, it's going to be 5 miles before you get to the mountain. Might be well worth knowing whether you're going to be able to cross it or not. Might determine whether or not you keep going or whether you set your wagons and make camp there and settle there.
Yeah.
But I've always thought that it's very clever that you can figure out the height of that mountain based on just 2 readings and knowing how far you traveled between the readings. In other words, you don't need to know the distance to the mountain, but you do need to know this distance you move. And that can be anything. You could go 1,000 feet, you could go 100 feet, you could go 10,000 feet. Obviously, the further you go, the more accurate your reading is going to be. If I only went 100 feet, now my accuracy is liable to be off a little bit because I'm 100 miles from that mountain and I'm only taking a reading after 100 feet. So, but very similar problem to, actually that problem there produces 2 equations and 2 unknowns, and that's what allows you to solve it. Is you end up with 2 unknowns, but you have 2 equations. So.
All right. So the next one is evaluate without using a calculator by using ratios in a reference triangle. And the question is sine 5 pi over 6.
When they say use a reference triangle, they mean that if I were to draw that angle, the resultant reference triangle would be that one right there, the triangle that is made with the x-axis.
Yeah.
Now, when you end up in a different quadrant, the way I think the best way to solve it always is using these rules. These rules basically tell you what that reference angle is. In other words, if that angle was 5 pi over 6, what is theta going to be?
Theta would be some variation of
it's
30
pi,
degrees.
It's pi minus 5 pi over 6, so theta ends up being pi over 6.
Yeah.
And this whole point of these formulas is that what we're doing is figuring out this reference angle. And it turns out that it's going to have the same absolute value reading as pi over 6. And in fact, no matter what quadrant you're in, if you apply these formulas, then you will get the equivalent first quadrant angle. And from there, we know what the numerical value is, and then using all students take calculus allows us to put a plus or minus sign on it that's proper. So if I'm doing sine of 5 pi over 6, here's my process. I know it's in the second quadrant. So it is the equivalent of, here, and I found a new way to write this, which I kind of like. It's the equivalent of pi over 6. Well, that's 1/2. And then because it's in the second quadrant, I know it's positive because it's sine. So there's your answer. And it's as simple as that, no matter what angle they give you. Let's do some more. It's another one.
Well, that was the only one that is on my worksheet.
Let me make some up.
Because we've been doing our entire worksheet. It's just the instructions worded so you would think that there would be more, but there aren't.
It's okay. This is very important. So you definitely need to be able to do these. So let's practice a few of them. So how would I do cosine of 7 pi over 6?
Well...
Which quadrant?
So...
Figure out the quadrant.
Fourth.
No. This is pi over 2. This is pi. This is 3 pi over 2.
Okay, so then it would be...
Third.
Would it... Third quadrant.
So what's its equivalent? What is its reference angle? Or what I would call the equivalent first quadrant angle?
It would be 30.
Right. It would be pi over 6. Because I'm going to apply this right here. I'm going to take 7 pi over 6 minus pi, which leaves pi over 6. What's the cosine of pi over 6?
The cosine of pi over 6 is... It's
square root of 3 over 2. What is its plus or minus sign in the third quadrant? Cosine.
It would be minus.
Okay, there's your answer. Now, that is a very simple way to do these kind of problems, is to immediately figure out which quadrant, therefore which formula do I use to convert it to either a first quadrant angle or that reference angle that they are speaking about. Figure out its numerical value based on that first quadrant angle and then put the sign on it. And every one of them you can do exactly like that.
Mm-hmm.
What's the tangent of 210 degrees?
It's in the third quadrant.
Okay.
And it'll be positive because it's tangent.
Okay.
And
what's its reference angle?
It is 30 degrees.
Right, because you'd want to substitute 180 for pi. In other words, when you're dealing in degrees, you use these formulas. So it'd be the same as the tangent of 30 degrees. The tangent of 30 degrees is 1 over root 3, or rationalized root 3 over 3. And like you said, it's positive. Although I usually wait until I don't put the sign on it until the last step. In other words, I do it in a 4-step process every time. I figure out which quadrant, what the equivalent first quadrant angle is, what the numerical value is, and what the plus or minus sign is, in that order.
Yeah. Yeah.
Okay. And as long as you know those two triangles, the 30-60 and the 45-45, then you can always figure out what the equivalent first quadrant numbers are.
Yeah.
by just figuring out the ratio based on those two triangles right there. So if you have everything on this page memorized that you can see right now, then it will allow you to answer any trig function for any multiple of 30, 60, or 45 degrees.
All right. Can you leave that up for
Sure.
a second? I wanna. All right.
Okay. I probably draw this page about 50 times a year. And I tell everybody the same thing. Memorize everything you're looking at.
Yeah.
Okay.
All right. So next question is find the measures of two angles, one positive and one negative, that are coterminal with the given angle of 108 degrees.
Okay. What's a positive coterminal angle going to be?
Positive coterminal angle. So that is a...
Just add 360 to it.
Yeah, so that would be, yeah, 460.
And if you subtract 360, you will get a negative.
It's 252.
There's your two answers.
Yep.
And you can add or subtract any multiple of 360. So if they asked the same question and they said, okay, give me these answers for starting with 730, what would you do? Now let's make it a little easier. Let's start with 390. Give me a positive and a negative coterminal angle to 390.
Well, I would subtract 360
Okay.
and get 10, and then subtract it again. Or, yeah, 30, and then subtract 360 again and get a negative.
There's your two answers. So it isn't always adding 360 or subtracting 360. It's getting it inside the unit circle with a positive and a negative sign. Notice both of these angles are inside the unit circle. One's positive, one's negative. So however many multiples of 360 you have to subtract or add, you can.
Yep.
What else?
All right. Last question was identify the maximum and minimum values of the function y equals negative 6 sine of x.
What's the maximum that value can be?
Would it be 6?
Yeah.
No.
Yeah, because if we look at the range on sine x, the range is -1 to 1. It's never greater than 1, and it's never less than 1, -1. In other words, it goes on forever. So the maximum that can ever be is +1, which would make -6, and the minimum it could ever be would be -1, which would make +6. So there's your min and your max, -6 to +6.
Okay.
That do it?
And that was actually, yeah, that was the last question I had.
Okay. That's a pretty good review for trig, actually. That was a lot of questions. But I think you're in pretty good shape. I think you understand it pretty good.
All right.
Okay, Lucas, I'll talk to you next week.
All right.
Bye-bye.
Talk to you